Welcome to lesson 2 of our very informal ConquerHSC holiday course of finance. Today we're gonna start looking at annuities. Just looking at what are they and how are they different from compound interest. So I just moved down to the syllabus dot points. I'll leave that for you to read. But yeah, you have to identify an annuity as a blah blah blah. You have to know what it is. So this is my interpretation. Must learn what an annuity is, how annuities are related to compound interest, but are a completely different beast altogether. That's the first thing we'll do. And then we have to learn what a recurrence relation is, and we'll see how annuities can be calculated using a recurrence formula. And lastly, we'll have a really quick look at graphically exploring annuities and just having a look at them in general. Okay, so first thing, what is an annuity? And I've made this small spreadsheet. Hopefully we can have a look at it. So compound interest, we're going to look at this one first. What is compound interest? Okay, so compound interest is basically, these are the conditions before we get started. Any money we invest, anything we look at today in this particular spreadsheet, the rule is it's going to compound monthly. The interest is going to be 1% per month. The deposit is going to be at the start of each month. We're going to place that money at the start of each month. So let's have a look at compound interest. In compound interest, what happens is you invest $10,000 at the start of the year. In January 1st, for example, you invest $10,000. Now, what happens in compound interest? What happens is if you put $10,000 into your bank account, then in February, because your money has been in the bank account for 1 month. See, that's the thing with interest. I should have probably explained this yesterday. Interest is the extra money. It's the price of money, in essence. So if I give money to the bank, if I invest money in the bank can use my money for however long I've invested the money. And for this privilege, for this facility, whatever you want to call it, the bank will give me money. It will pay me money because money has value. If I had $1 million right now, I could invest that. I could buy a house, and the house would appreciate over time. I could invest it in a business, and I would get more money. So money is valuable. Money and time have a special relationship. If you have money, you can use that money to earn more money. So money has this property of being valuable, not just for its spending, its spending power, but also the fact that when you have money, you can spend it to get even more money. And that's really what interest is. Interest is, if I give money to the bank, then the bank is going to pay me for that privilege. And because I've invested money in the bank, $10,000 January 1, on February 1, this money will have increased. The bank is going to give me money. So how much will it give me? Well, it's going to give me $10,000, and it's going to multiply by how much it compounds. It compounds per month, and the interest rate is 1% per month. So it's going to go up in value by, and we can use the compound interest formula, 1 plus interest rate, which is 0.01. And that's how much money I will have in the bank in February. Now I'm going to keep the money in the bank, but now it's going to appreciate by March. Now, I'm not going to get 1% of 10,000 anymore. I'm going to get 1% of whatever I had in February. And so if I just drag this down, you see that the money has appreciated by more. So from January to February increased by 100, but from February to March it increased by $101, not by $100. So it's going to get bigger and bigger, faster and faster. And we can kind of see this over here. This is a compound interest graph, I suppose. Now, let's say I increase the interest rate, so it's a bit easier to see. It increases at an increasing rate. It'll get bigger and bigger. The sum of money I've invested in the bank will get bigger and bigger and bigger and bigger at a faster rate. Okay, now, if you think about the compound interest formula, which we did yesterday, or in the previous lesson, A equals to P, 1 plus R all to the N, that's a variable. And it's going to increase in time. That's going to increase, right? And so really, this whole thing is an exponential equation. Because what happens when you have y equals a to the x? What's the graph of that? And as you guys should know, it looks like something like that, right? So the variable is a power, more or less. You have an exponential curve. And so the compound interest formula should remind you of an exponential curve. And that's why compound interest, it increases like an exponential curve, as you can see over here. Right, and I can make this, I guess, hopefully you'll be able to see it a bit more clearly. So yes, as you can see, increasing interest rate makes the exponential curve a bit more pronounced, so you can hopefully see it a bit more clearly. Alright, so that's simple interest, and look, we can drag this all the way till the end, and you know, at the end of the year, you'll have $11,268.25. Now, the important thing here is we deposited money once, okay, in January. That's it. We deposited money once. So what is an annuity? Compound interest is one deposit, and it earns interest over time. An annuity, on the other hand, is many deposits at regular intervals. That is really the key, and they'll all earn interest over time. So here we have an annuity. This is let's say this is the annuity, right? Now you have $10,000, and let's say you deposit in January. You're going to deposit $10,000. In February, you're going to deposit another $10,000. In March, you'll deposit another $10,000. And every month, you will deposit $10,000. Every single month. And all of these will appreciate. All of them. And so that is December. Last month, you'll deposit $10,000 as well. And all of these will gain interest over time. So, for example, is equal to the one above multiplied by 1 plus, what is the interest rate? 0.01. And just make this a bit wider. What happens over here? Y F is equal to, sorry, this is equal to the one above 1.01. I've got no idea why it's doing that. Oh, there we go, sorry. I was just missing the multiplication sign. Alright, so that earns interest all the way till December. And this is exactly the same. The deposit in February will also earn interest every single month, multiplied by 1.01. And that will also earn interest all the way till the end. So we're talking about an annuity, okay? An annuity is where you have multiple deposits. Okay? Annuity has many deposits at regular intervals, and they all earn interest over time. And whatever you have, you add all of these up at the end. You'll add all of these up at the end. So it's going to be this, and then this is going to equal to that. And you know what? I'll stop being lazy, and we'll just do these real quick. Multiplied by 1.01, and I'll copy this. Yeah, just filling all these in. Sorry, it won't be long. Is equal to this multiplied by, is equal to that multiplied by, just bear with me. And that's December. It will actually doesn't matter, whatever. I think there should have been an extra column here. That's okay. You get the idea. I made a slight mistake, but that's okay. I don't want to waste too much time. The point is, really, all of it is going to equal to you know, Murphy's law. Everything that can go wrong will go wrong at the worst possible moment. I made the whole spreadsheet, and then time of recording this happens, but that's okay. I'm sure you'll bear with it. And this is just going to equal to, can I sum it? Where is it? Auto sum. Auto sum. All of those. Yes, so the annuity will be worth $126,825. So with the compound interest, we deposited $10,000. We deposited $10,000. We ended up with $11,268 at the end of the year. With an annuity of $10,000, right? An annuity of $10,000 is not the same as a compound interest question of where you deposit $10,000, because an annuity is you depositing $10,000 every month. It's multiple deposits, and they all gain interest over time. Now, this is what this stuff, annuities, is what Maths Advanced Finance is all about. Okay, compound interest is it's a very small part of finance and maths. Annuities is the bread and butter. It's basically what all of finance is about in maths. The rest of finance in Maths Advanced is pretty much all about annuities. So you have to really understand that annuities, multiple deposits, they all gain interest over time, and you sum it up, and that is the future value of the annuity. This is what the annuity is worth at the end of the year. Okay, if you deposited $10,000 every single month, if you had an annuity of $10,000, how much would it be worth at the end of 1 year? That's what it would be worth, given the these conditions. So hopefully you've understood. Pause the video, rewatch it, make sure you understand. Ask questions on Discord if needed. Now, annuities can take an alternative form too, a single large investment from which many withdrawals are taken out regularly. So here's this one really quickly. I didn't set up a spreadsheet over here, but this is a normal annuity where you're depositing $1,000, interest rate 0.09 or 9%, number of deposits 12. This is a regular investment type annuity. You're depositing. They're all gaining interest over time. That's what it looks like. Somewhat similar. The curve is somewhat similar to a compound interest curve, but we are talking about an annuity here, right? Every single month you're adding another 1,000, and it's compounding and so on and so forth. So that's why you can see it's increasing so much. This is very different to a compound interest one. And the other type of an annuity is where you borrow a large amount of money, like a home loan, for example, where you borrow $700,000 and then you're making deposits, you're making repayments, not deposits, you're making repayments, you're paying back the loan over time. And so you're starting off with $700,000, you make the $700,000 will increase, will compound, but you're also making a deposit, not a deposit, you're also making a repayment, so the total amount that you owe will go down over time. Okay, and it goes down, as you can see from the graph. So this is also an annuity because you're making regular deposits or regular repayments. Okay, many of them, not just one. So that's the key to an annuity. It's not about one deposit, it's about many deposits at regular intervals. Okay, or a single large investment or a loan from which many withdrawals are taken out or many repayments are made. Really depends on the question, but that's really the key. You have a large amount of money which is going to keep compounding, but you're making regular scheduled repayments or withdrawals, whatever depends on the question, but hopefully you understand. Make sure you ask on Discord if you're not clear. Okay. Alright, so we'll move on to the next thing, which was learn what a recurrence relation is. Hopefully you understand what an annuity is, and ask on Discord if you do not, okay? Recurrence relation. A recurrence relation is simply a special type of an equation. In a recurrence relation equation, to find the next value, you need to know the previous value or values. That's pretty much it. That's it. So the Fibonacci sequence, hopefully you learned that sometime in primary school, hopefully. The Fibonacci numbers go something like this. You start off with 1 and 1, and then you add these two up to get 2. Okay? And to get the next number, you're going to add the previous two numbers. 1 plus 2 is 3. To get the next one, once again, you add the previous 2. 2 plus 3 is 5. And that's recurrence relation. That's recurrence relation, where to get the next number, you need to do something to the previous number or numbers. Okay, so we can write that in mathematical notation. So if you had something like, for example, and this is the example I've used over here, if this is a random example, if you add, to get the nth term, you need to get the previous term, the n minus 1th term, and you add 5. Okay, that would be an example of a recurrence relation. And look, we learned in series and sequences, if you're making regular differences, that's an arithmetic sum, isn't it? Like, so if you had, for example, 1, 6, 11, 16, ... and it goes on forever. That's clearly an arithmetic sequence because there's a common difference between the terms, a difference of 5. So one way to write this would be a is equal to 1 plus the difference. So it'd be a plus n minus 1 d. That's one way to write, that's one way to describe this sequence using algebraic terminology. Look, I'm not filling it in, it doesn't matter. The point is, that's one way to write it. Another way to write it would be, to get the nth term, you get the n minus 1th term, and you add 5. So there's two different ways to describe this formula. Hopefully you can see that. You can do the a plus n minus 1d is equal to the nth term. That's the, arithmetic sequence formula. Or you can use a recurrence relation. Recurrence relation is a special type of equation. In a recurrence relation equation, to find the next term, you need to use the immediately previous term. And that's pretty much it. That's what a recurrence relation is. To get the nth term, use the term previous, or you can use multiple terms in the Fibonacci sequence, or use the previous 2 terms to get the next term. You get the last term, you add 5, you get the next term. That's pretty much it. And look, you can look through a formal way to describe it. Make sure you understand that. So the Fibonacci sequence could be described as follows. The 0th term, the Fibonacci 0th number is 0, first number is 1, and then the nth term is always going to be n minus 1 plus n minus 2. So for example, the 10th term will be the 9th term plus the 8th term, right? 10 is equal to 10 minus 1, which is 9, 10 minus 2, which is 8. So to get the 10th term, you do the 9th term and the 8th term. Alternatively, another way to describe it would be the n plus 2th term is the n plus 1th term plus the nth term. So there's two ways to describe it, but hopefully you see what a recurrence relation is. Okay, so why did we learn recurrence relation? Because you have to learn how annuities can be calculated using a recurrence formula. Okay, now I can't stress enough, this is really important. You need to know what an annuity is, and then you need to understand how you can use a recurrence relation to calculate annuities, because this forms the backbone of the hard questions that we'll do later on. You need to understand this. Now, there's no homework today. It's just a theoretical topic today, so you need to really understand. So annuities as a recurrence relation. So we learned that in compound interest, sorry, let's just go back over here. We learned in compound interest, we did this. And if you noticed, we used the previous term to get the nth term. Now, let me use a calculator to demonstrate. There's two ways to think about a compound interest formula, okay? So we're going to compound interest before we move on to annuities. I was hoping the lesson wouldn't take this long, but look, it's important that you understand. So I'm sorry it's taking a bit longer than I thought, and perhaps you thought as well. So compound interest, you can do it using two different ways, and then we'll move on to annuities in a second. So, for example, you deposited $10,000 in January. How much is it worth in February? One way to do this is to use the compound interest formula, which is $10,000, and you have 1 plus interest rate was 0.01. 1% per month to the power of 1. It'll compound once. And here you get $10,100. As you can see over here, in February, you'll have $10,100. And in 2 months' time, you'll have $10,201. As you see over here, $10,201. So you can certainly use the compound interest formula. And we can keep going it, and you'll see that you'll keep getting the values as we did in the spreadsheet. So that's one way to do it. That is using an algebraic equation. Now, another way to get the compound interest formula is to use a recurrence relation. Let's see how we can model that on our calculator. Okay, so you have $10,000. Now what I'm going to do is I'm going to say answer, and the answer is going to act as our previous term, right? because that's what a recurrence relation is. We're going to use our previous term to get the next term. Now, what happens to our previous term? Whatever we had previously is going to compound. So we're going to do multiplied by, and how much is going to compound by? 1 plus 0.01. Okay, or yeah, so that's our previous value, whatever it was, and it's going to compound once. And so we had $10,000, now we'll get 10,100. Now if I press equals again, the answer over here, it's going to use this value, our last value, and it's going to compound. So 10,201, 10,303.1, 406.04, you can round it off and so on. And you keep going and you'll end up with 11,156.68. So this is another way to calculate compound interest using a recurrence relation. Hopefully you understand. We're using our previous value and we're just compounding it once. That's really all the normal interest, the normal compound interest formula does as well. Now we move on to annuities. How can we do annuities using a recurrence relation? So that was one way to do it, where you treat annuity as a sum of separate deposits, all of which compound. And look, we'll do this algebraically when we get to... Sorry. OneNote does this sometimes, it doesn't scroll, I don't know why. Okay, so when we do method 1, we use GP as a sum of multiple, we sum of a GP on multiple investments. That's method 1 of dealing with investment types, which is what we've just covered. And then the more complicated version is where we use sum of GP on a single compounding amount, which uses annuities as a recurrence relation. So the stuff we're doing today does form the backbone of the future stuff, especially with reducing balance loans, which is probably the hardest type of question in this particular subject and this particular topic. We use annuities as a recurrence relation. We don't call it as such, but that's how you deal with it, and we do it algebraically, and it gets very, very, very long. But that's okay, we'll get to it when we get to it, okay? So let's just think about how we can think about annuities as a recurrence relation. So we've seen how we can do annuities using the normal way, quote unquote. Annuities treated as a sum of separate deposits. Let's look at it from a recurrence relation perspective. So what happens in February? What actually happens in February? What happens in February? So we're doing equals to, right? What happens in February is that the $10,000 we deposited in January will compound once. Compounds once, right? But we also add another $10,000. So we add another $10,000. And as you can see over here, that's what happened. So if you think about it from this perspective, in February, what happened? We had the $10,000, it compounded once, and you added another $10,000. So really, in February, how much did you have? In February, you had this plus this. So 20,100, exactly as we can see over here. That's what we had in February. Now, we are using a recurrence equation, right? So what that means is we're going to use our previous, whatever we had in February. What happens to what we had in February? It'll compound once. It'll increase once. It'll compound once. And we'll add another $10,000. And as you can see, we're just going to keep repeating that. And we'll take it all the way to the end. And we'll see that 126,825, 126,825. So it's another way to deal with annuities. It's a slightly different way. You have to understand the theory and the concept of why and how it works and what it's all about, because we're going to use this in the hard questions. This is how we start off the harder questions, all of the harder ones. And once again, if you have any questions whatsoever, make sure you ask on Discord. Okay, so once again, it's refusing to scroll. So let's just... Okay, so we've done recurrence. Annuities is a recurrence relationship. Look, you feel free to pause the video, read through the text explanation. I have covered it using Excel, hopefully. And also, by the way, we did this using Excel. You can model this on a calculator as well. Now the syllabus dot points just says use technology to model an annuity. And look, the calculator is a piece of technology, and it's very powerful. It's very cool, actually. So let's just do this on a calculator. In January, you had $10,000, right? Cool. But what about in February? What happened in February is your previous value, it compounded once, 1.01, and you added $10,000 to it. And you press equals 20,100. In March, the same thing's going to happen. Our previous value is going to compound once, and it will add 10,000. So I can just press the equal sign now, and it'll do it for me. I just keep pressing the equal sign, and it's going to get all of these values. So look over here, and it's just getting all of them. Pause video, examine if you're certain, if you're uncertain or you're skeptical or whatever. Look at it. It's getting 72,000, 82,000, 93,000, 104,000, 115,000, 126,000. So this is a recurrence relationship where you use the previous value to get the next value. And an annuity, what happens is the previous value, whatever you had at the end of last month, it compounds once and you add $10,000. That's really the key between the difference between compound interest and an annuity. An annuity, you're regularly depositing more money. The same amount of money you deposit every single month or every single time period, but you deposit it every single time, like at regular intervals. And the previous value compounds once as well. Okay, so I believe that's it. And once again, just review. Okay, so we've covered that. Effective changing variables and annuities. Look, this video really, might as well make it go up to half an hour. So looking over here, this is an investment type annuity. If I mess around with deposits, hopefully, just think about, predict. The best way to learn this type of stuff is make a prediction. What will happen if I make more deposits? So make a prediction. Pause the video, make a prediction, see if you're accurate. That's what happened to the graph. Okay, now what if I make that 800? Once again, pause the video, make a prediction, see what happens, and then check your answer. And so let's just reset that back to 1,000. And now we're going to play around with the interest rate. What happens to the interest rate? If I increase the interest rate, what will happen to the curve? Pause the video, make a prediction. So I'm increasing the interest rate from 9% to 15%. That's what happens. And what about if I make it, 5%? Pause the video, make a prediction, see what happens. And there we go. And look, I'm happy. If you want to play around with this on your own, I'm more than happy to upload this to Discord. You can play around with the values. Or you can do it yourself, really. Honestly, it's a good exercise. Might as well learn Excel. It's not particularly complicated. And it'll be a good exercise. It'll test your understanding of annuities. But look, I understand that not everyone knows Excel and many people find it daunting. So that's okay. I'm happy to upload this spreadsheet and you can play around with it on your own. And so that's the first type of annuity, an investment annuity. You also have a reducing balance loan. That's what the syllabus calls it. You don't have to worry too much. The point is you have a large amount of borrowing, initial loan. Let's say it's a home loan, for example, $700,000, and you're making regular repayments. Now it's interesting to note what happens if you don't make a large enough repayment. So this is what happens if you don't make a large enough repayment. And hey, you're actually not going to pay back the loan. If you're not paying back enough, then that sum of money is going to compound more than you're paying off. So it's just going to keep increasing because you're not paying back enough. You're not even paying back the interest. Okay, so you have to be paying back the interest. Now I believe I was playing around with this earlier. No, sorry. I really don't remember what it was. 2,700. I don't remember. It doesn't matter. So there's a certain amount of a certain combination of these where the compound interest won't increase and won't decrease. You will never pay back what you owe. It'll remain the same because the amount that you're paying back, your repayments, are equal to the interest that you're gaining every time period. Okay, so anyway, let's say you had taken a home loan for $700,000. Each repayment, let's say, is $3,000, and you're paying back per month. Repayments per year is 12. That's what happens. What if you return $2,000, but you do it, once a fortnight? Repayments per year will be 26. So that's what happens. What about if the interest rate increases? Make a prediction. So look, honestly, this is not really a teaching dot point, I suppose. It's more like, use technology to model an annuity and investigate. So it's more for you to investigate. You should have done this in class, but if you didn't, that's okay. Like I said, ask me on Discord, and I'll be happy to upload the spreadsheets for you to play around with. It's more an investigation thing, something you have to learn. Just get a feel for it. I have seen HSC questions where they give you a question something like this, and they say, what happens if the interest rate changes? What will the new graph look like? So it is important that you investigate it and just get a feel for what happens, because I believe it was in last year's HSC exam or the year before, I don't remember. I've definitely seen it. And yeah, so that's it for today. We've covered everything that I was supposed to cover for this lesson. Hopefully you have understood what an annuity is, how annuities are related to compound interest, but they're completely different altogether. Hopefully you've learned what a recurrence relation is, and you've learned how annuities can be modeled and calculated using your recurrence formula, both using Excel and using your calculator. And lastly, for the third one, that's something for you to explore, for you to play around with. I'm happy to upload a spreadsheet. In fact, I'll definitely upload it when I make this post on ConquerHSC. So best of luck. There's no homework today, but it's very important that you get a feel for everything we've studied today, really understand it, because it's going to form the backbone of the future topics. So best of luck.